What's up guys? Welcome back to my another vid, and for this vid I will be doing the chapter 11, the summary of chapter 11. So if you want to learn something about the chapter 11, if you want to get some informations from me, please stay watching the station and I'll be back guys. So chapter 11, build a small network. So up to this point in this course, we have considered the services that a data network can provide. So to the human network, examine the figures of each layer of the OSI model and the operations of TCP or IP protocols, and look in detail at the Ethernet, a universal LAN technology. And the next step is to learn how to assemble these elements together in a functioning network that can be maintained. So, small network topologies. The majority of businesses are small, so it is not surprising then that the majority of networks are also small. So a typical small business network is shown, and with small networks, the design of the network is usually simple. The number and type of devices included are significantly reduced compared to that of a larger network. So the network topologies typically involve a single router and one or more switches. So small networks may also have wireless access points, possibly built into the router and IP phones. So as for connection to the internet, normally a small network has a single one connection provided by DSL, cable, or an Ethernet connection. So managing a small network requires many of the same skills as those required for managing a larger one. So the majority of work is focused on maintenance and troubleshooting of existing equipment, as well as securing devices and information on the network. So the management of a small network is either done by an employee of the company or a person contracted by the company. So depending on the size and type of the business. So the common applications. The network is only as useful as the applications that are on it. And there are two forms of software programs or processes that provides access to the network, and network applications and application layer services. So network applications. Applications are the software programs used to communicate over the network. So some end user applications are network aware. So meaning that they implement application layer protocols and are able to communicate directly with the lower layers of the protocol stack. So email clients and web browsers are examples of this type of application. So application layer services. Other programs may need the assistance of applications layer services to use network resources like file transfer or network range spooling. Though transparent to an employee, these services are the programs that interface with the network and prepare the data for transfer. So different types of data, whether text, graphics, or video, require different network services to ensure that they are properly prepared for processing by the functions occurring at the lower layers of the OSI model. So each application or network service uses protocols, so which define the standards and data formats to be used. So without protocols, the data network would not have a common way to format and direct data. In order to understand the function of various network services, and it is necessary to become familiar with the underlying protocols that govern their operation. So, the types of threats. So, whether wired or wireless, computer networks are essential to everyday activities. Individuals and organizations alike depend on their computers and networks. Intrusion by an unauthorized person can result in costly network outages and loss of work. So attacks on a network can be devastating and can result in a loss of time and money due to damage or theft of important information or assets. Intruders can gain access to a network through software vulnerabilities. Hardware attacks are through guessing someone's username and password, and intruders who gain access by modifying software exploiting software vulnerabilities are often called hackers. So there are four types of security theft. So the first one is the information theft. So this is breaking into a computer to obtain confidential information. So information can be used or sold for various purposes. An example is stealing an organization's proprietary information such as research and development information. And the next one is the data loss and manipulation. So this is breaking into a computer to destroy or alter data records. So examples of data loss is sending a viruses that reformat a computer's hard drive. Examples of data manipulation is breaking into a record system to change information such as the price of an item. Then the next one is the identity theft. This is a form of information theft where personal information is stolen for the purpose of taking over someone's identity. So using this information, an individual can obtain legal documents, apply for credit, and make unauthorized online purchases. And identity theft is a growing problem costing billions of dollars per year. Then the last one is the disruption of service. This is preventing legitimate users from accessing services to which they should be entitled. Examples: denial of service or the DOs. Attacks on servers, network devices, or network communications links. So the backup, upgrade, update, and patch. So keeping up to date with the latest developments can lead to a more effective defense against network attacks. As new malware is released, enterprises needs to keep current with the latest versions of an antivirus software. So the most effective way to mitigate worm attack is to download security updates from the operating system vendor and patch all vulnerable systems. So administering numerous systems involves the creation of a standard software image, operating system, and accredited applications that are authorized for use on client systems that is deployed on new or upgraded systems. So however, security requirements change and already deployed systems may need to have updated security patches installed. So one solution to the management of critical security patches is to create a central patch server that all systems must communicate with after a set period of time, and any patches that are not applied to a host are automatically downloaded from the patch server and installed without user the intervention. So the interpreting ping results. So using the ping command is an effective way to test connectivity. So the ping command uses the Internet Control Message Protocol, or the ICMP, and verifies layer 3 connectivity. So the ping command will not always pinpoint the nature of a problem, but it can help to identify the source of the problem, an important first step in troubleshooting a network failure. The iOS ping indicators, a ping issued from the iOS will yield one of the several indications for each ICMP echo request that was sent. So the most common indicators are: the first one is the exclamation point, indicates receipt of an ICMP echo reply message. The next one is the dot, indicates a time experience while waiting for an ICMP echo reply message. And the last one is the letter U, an ICMP unreachable message was received. So the dot period may indicate that connectivity problem occurs somewhere along the path. Then the U indicates that a router along the path responded with an ICMP unreachable message. The router they have not route to the destination address, or that the ping request was blocked. So the testing the loopback. The ping command can also be used to verify the internal IP configuration of the local host by pinging the loopback address. So the basic troubleshooting approaches is network problems can be simple or complex and can result from a combination of hardware, software, and connectivity issues. So technicians must be able to analyze the problem and determine the cause of the error before they can resolve the network issue. So this process is called troubleshooting. And in order to meet user requirements, even small networks require planning and design. So planning ensures that all requirements, cost factors, and deployment options are given due consideration. An important part of a network design is reliability, scalability, and availability. So that's all guys for this vid, and thank you for watching, and I hope you guys get some information about the chapter 11, and thank you for watching guys. See you.